Hello, my name is Aaryan Chatterjee and this is my magnetic field of a magnet lab 4 in physics 2212. In real life, certain objects have something called a magnetic field associated with them, like Earth. This lab will focus on analyzing magnetic fields and their relationship to distance. More specifically, the purpose of this lab is to analyze and measure the magnetic field of a bar magnet. In this experiment, we will have an observational and computational model, which will both measure the magnetic field. Later, we will see that our models provide similar results, and that the magnetic dipole moment is about 1.98, and n was around -3. Now, before we jump in straight into the lab specifics, I think it's important to understand some of the crucial physics principles and ideas utilized in this lab. Firstly, it's important that everyone understands the Biot-Savart law, which models the magnetic field of a point with the equation shown on the slide. And from this equation, we can send into the equation for the magnetic field of a dipole, which is in the top right. And it's important to note that that magnetic field is dependent on the distance from the source, and that is shown by the equation on the bottom left. And that equation is then linearized to become the equation shown in the bottom right. And we will use these two equations later on in this lab. Now we must cover some major assumptions in the experiment, and one is that there are no external factors that are affecting the bar magnet or the phone in the experiment. This means that we're only considering the bar magnet magnetic field to be present in the experiment. Additionally, everything is assumed to be properly aligned on Earth's magnetic north. On top of the assumptions, it is important to know that the system, which is what we will analyze, is the bar magnet in the experiment, and that everything else is surroundings like Earth, the table, and much more. Now for the experiment, we'll use an app on our phone to measure the magnetic field from the bar magnet at different distances apart. Additionally, we will measure the field of the bar magnet on axis and off axis, but to start collecting data, the most important step was to find the phone's magnetometer, and then find the distance from the bar magnet. After that, we could start collecting data. Moving on to our data, we first decided to measure the magnetic field from the bar magnet on axis. On the left side of the picture, we have our distance values of the phone and the bar magnet in order to create a magnetic field of a certain strength. The distances in the magnetic fields are then averaged and linearized into a graph, and the equation which is shown on the right side. Now that we have the linearized equation between the distance and the magnetic field, we can determine what k and n are in the exponential distance and magnetic field equation. And after I found n to be around -3 and k to be around -14.7, and the math is shown on the screen. And after that, I set the magnetic field equations that we know equal to each other and solve for the magnetic dipole moment, since everything else in the equation is known. And that tells us that the magnetic dipole moment is 1.98 amperes times meters squared. Then moving on to the rest of our data collection, we started to find the magnetic field at a perpendicular point at a certain distance away, which was 0.16 meters in this case. And as you can see, we found the magnetic field off axis of the bar magnet and is shown in the bottom table. Now, moving on to the code, we first create the bar magnet in the code, then I put the value of the magnetic dipole moment that we calculated earlier in the lab, and then I created a function to find the magnetic field at a certain point. Then I initialized the axes and other values so that the rest of the code would work properly. This is just the setup code. The next slide will be the real code. So, in these code pictures, I found the magnetic field on axis and off axis using the values I set earlier and the function I created to find the magnetic field at a certain point. And additionally, I created arrows for these fields and printed out the values of all the fields so that we could see the values when we actually run the code. And looking at the visualization, there are all the arrows I coded, and the orange arrows are on-axis magnetic fields, and the blue arrows are off-axis magnetic fields. Additionally, the purple arrow is the off-axis magnetic field that we calculated in the experiment, and since the values of the magnetic fields are printed on the side, we can see that our results were pretty similar. Now, although our lab provided pretty accurate measurements, there could have been some sources of error. For instance, the magnetic field was definitely affected by some things other than the bar magnet, since the lab was full of many other magnetic objects. Additionally, the ruler and the bar magnet may have not been perfectly aligned with the Earth's magnetic field, which affects the data. And finally, there could have been some human error, since we could have shifted the ruler or phone by accident, affecting the distances. For the what-if questions, if our meter stick was at some intermediate angle with respect to Earth's magnetic field and was not properly aligned like in the experiment, then the Earth's magnetic field would affect the readings and the experiment, giving us inaccurate results. Additionally, if two identical magnets were stuck end to end and used in the experiment, then the measurement for the magnetic field should double with the same direction. Now that's all from our presentation. Thank you for listening.